So this is the reason the ESR doesn't give a good information to us until and unless any reaction is following a free radical mechanism. So NMR is opposite to that. In NMR, we are having unpaired nucleons. Keeping in mind, just like if you look at this, let's say this is an electron. If you remember, electron has a negative charge. If a body, anything which have a body mass m, and it revolves, it spins, it always produces a magnetic field. So if you have an electron is spinning, it is charged, it has a specific charge, it is spinning, and the charge on electron is 1.6 10 to the power minus 19 coulomb. You have seen this was J.J. Thomson calculated this. You would have definitely come across in early discoveries in physics and in physical chemistry as well, J.J. Thomson experiments. So who calculated the charge on electron and on proton, etc. So anyhow, this is the charge on electron, which is 1.6 10 to the power minus 19 coulomb. So this electron, when spinning, it has a little mass. If you are comparing with the mass of a proton or a neutron, it has a very small mass, very little mass. So if you remember, this mass is very low. If you compare this mass with the mass of the new proton, it is 1836 times less. If you compare this with the mass of neutron, it is 1837 times less than that. The mass of proton and neutron is not same. The mass of a neutron is slightly higher than proton, right? So proton has a slight, if we are comparing with, if you have 1836 electrons, and this is equal to the mass of one proton. If you collect 1837 electrons, it is equal to the mass of one neutron. So mass of proton and neutron has a one uh, basically a unit less than the neutron. So proton and neutron are having positive charge, but their charge is also same. It is 1.6 10 to the power minus 19 coulomb. So when proton, neutron carries no charge. Electron carries negative charge. Proton carries positive charge. So this magnetic field generation is not dependent to charge, that the body should be charged. If it is a neutral, again it shall produce magnetic field. Like our earth is not charged. It doesn't carry positive or negative overall charge on it. But when this earth is spinning, it is producing a magnetic field, right? Very similar is here. Very similar is here. When we have an electron, proton, or neutron, when all of them are spinning, they are producing magnetic field. All right. So very similar is here. Let's say we are having one electron which is charged, one proton which is also charged. So but neutron is uncharged. So electron, proton, neutron, any body, if spinning, it shall always produce magnetic field. Either it is charged or uncharged, doesn't make any difference. So this is the electron, neutron, or proton. In proton, in NMR, we are concerned with nucleus, proton and neutron. In case of ESR, we are concerned with electron unpaired. Let's say if we have unpaired atom, unpaired electron present in an organic molecule, so it shall be free radical possible only, right? So that free radical can be studied by ESR. But if we are having an unpaired nucleon, so proton and neutron are collectively called nucleons. So nucleons mean, whenever I say nucleons, so I mean proton and neutron. I am saying the statement for both. So in NMR, we use the term nucleons, mean proton and neutron collectively. So nucleons when spinning, they also produce magnetic fields, but they shall produce magnetic field if they are having such energy levels, mean they are not going to cancel out the effect of each. So just like you have come across the electronic fields, electronic energy level, similarly, there are nuclear energy levels as well. But keeping in mind, electrons are revolving around the nucleus. They are having a centrifugal force, which keep it away from the orbit. But there is a force of attraction of the nucleus because nucleus carries positive charge, electron carries negative charge. It should be attracted towards nucleus. But centrifugal force doesn't let it to go closer to the nucleus. On the other hand, it should go outside the orbit, but it is the force of attraction which doesn't allow it. According to Bohr's atomic model, this centrifugal force and force of attraction between nucleus and electron, they are equal. That's why it doesn't let it go outside its orbit or fall into the nucleus. This is what Bohr's atomic model start with derivation. You derive from here, centrifugal force is equal to force of attraction. So you make a derivation there. So this is the basic assumption in Bohr's atomic model. So same is applied. So if you have an unpaired electron, you are familiar with the electronic energy level, but you are not familiar with the nuclear energy level. That I shall introduce here. I shall introduce in NMR the nuclear energy levels. It also have a shell, subshells, magnetic, and spin quantum numbers. Very similar, just like electronic energy level. It also have nuclear energy level. I shall explain that energy levels just right now, but just look at one principle. Let's say we have an unpaired neutron or proton, unpaired, should be unpaired. If it is unpaired, it shall have a magnetic field. If it has a magnetic field, so we can resonate this one. So you shall see what resonance mean. Inversion in spin. If it is rotating clockwise, so we provide energy electromagnetic radiation which inverts its spin. From clockwise, it inverts to anti-clockwise. Or if it is moving anti-clockwise, it shall resonate to clockwise. This is called resonance. And because nuclear magnetic, because nuclear magnetic resonance, there is a resonance taking place in the magnetic field. Why? Look at this. If you remember, there is a principle we call right hand rule. Right hand rule. So in right hand rule, you have 4 fingers and 1 thumb. Fingers presents the position of magnetic field or spinning, and thumb presents the direction of magnetic field. Now look at here. If these are the, if it is spinning clockwise, you are looking from the top. This is clockwise rotation. So this is a spinning clockwise. So you shall point your right hand accordingly. 4 fingers are showing that they are spinning clockwise. Sorry, this is not clockwise. This is suppose anti-clockwise. Look at here. If you are looking from this, so this movement is anti-clockwise. Sorry, this is anti-clockwise. So if you place your fingers anti-clockwise, you see your thumb is upward. So here, this thumb is presented in the form of upward direction. This is the direction of magnetic field. Now let's say if it is spinning opposite, it is spinning like this. It is spinning clockwise, right? Clockwise. Then you shall have the direction opposite. This point shall be bottom end. So this thumb is presenting you the direction of magnetic field. And 4 fingers you are supposed to appoint if you make a punch in your hand. Direction of 4 fingers presents you the spinning, clockwise or anti-clockwise. So if you are looking it anti-clockwise, the thumb is upward. But if you are moving it clockwise, your thumb shall be downward. So this is very simple called right hand rule. Here, it has two possibilities. It can have a magnetic field in this direction, or it can have a magnetic field in this direction. If it is rotating anti-clockwise, like it is presented, then its magnetic field shall be upward. If it is spinning clockwise opposite to this, its magnetic field shall be downward. So what is nuclear magnetic resonance? In this case, we resonate. If it is spinning clockwise, then we provide energy which is discrete value for this to invert the spin of this. From clockwise it rotates to anti-clockwise, or from anti-clockwise it rotates to clockwise. In other words, if I define, if it has a nuclear spin in this direction, we revert this nuclear spin in this direction. The same is what we are saying, that if it is upward, it rotates downward. If it is downward, it rotates upward. This is what we call is a very simple resonance, nuclear magnetic resonance. This is the basic principle. And if this particle is electron, this is called ESR. But ESR need more energy, and neutron and proton needs less energy. Why? Now, this is very important critical question, that why electrons need more energy to resonate, and proton and neutron need less energy to resonate. Look at here. One we call charge density. In case of electron, the mass, what is charge density? Just like density is mass per unit volume. But what is charge density? Charge density means this is charge per unit volume. No, the charge on electron and charge on proton is same. It is 1.6 10 to the power minus 19 coulomb. But their mass or volume is different. The volume of electron is small, and the volume of proton and neutron is heavy. It is higher. Just like if you have a 1 gram body and one is 1836 gram body, definitely if they are of same material, they shall have a different volume. Let's say they are made up of plastic material. 1 gram body shall be just like a small palm. Small palm. And 1836 gram body would be just like a cricket ball, or higher than that, or maybe a football having the same mass. Compare the football versus 1 palm, small palm. So this is the just one I wanted to present, the comparison in their volume. So charge per unit volume is called charge density. Charge density of electron is high. Charge density of proton is small. Due to this reason, the energy level difference between the two states is less in case of this, and it is higher in case of electrons. So electrons, whenever they are spinning, they have high charge density. As a result, the difference between the two states, lower and higher. This is higher in case of ESR, and in case of NMR, this is small. I hope this shall be clear to everyone. Now, one process, if I am interested to present you, is very, very interesting. Let's see, this is a particle which is placed in a simple field. There is no magnetic field attached. Let's say this is one electron uncharged, or this is one proton uncharged. This is placed normally. So when it is placed normally, so it can have any direction of movement. No doubt it shall be have two only spins possible, clockwise or anti-clockwise. But this can be rotating. Let's say this ball, if rotates, so it can have a magnetic field in this direction, in this direction, in this direction, random. All right. So, but this is universal principle. When we place this tiny magnet in a strong magnetic field, now it cannot behave likewise. It cannot behave likewise. This is interesting feature. What I am going to present here, just I shall finish in a few couple of minutes, that whenever we are having this, just like if you have a magnetic compass, a magnetic bar with you, magnetic compass. So whenever you in your mobile, you are also having a magnetic compass. If you place magnetic compass, it always points towards north. Why? Because you are on this earth, it has a magnetic field. So this compass shall always point towards north, because whenever your compass is a small magnet and this earth is a extremely big magnet, the magnetic field of earth is very high as compared to the compass. So it always align. The one which have a lower magnetic field always align according to the strong magnetic field. This is the principle of physics you have seen in electricity and magnetism in early classes. So same is here. When we are having no magnetic field is applied on this molecule, so it is random. It has a random nuclear spin. But when we place this in a magnetic field, this B naught, is showing this is the strength of magnetic field, that we have a applied magnetic field, external magnetic field. So when we place same entity here, now when it is spinning, so it shall keep spinning, but one time shall reach when uh, when it was here, it was having a random spin. But when it is having here, so it shall have this nuclear spin. It shall be processional. This is called processional orbit. Processional orbit. If I exemplify this, let's see, you can experience it yourself. You have a top called Latu. So you have spin that as well. Keep looking at this. When this top is spinning, it keeps spinning, but with the passage of time, its frequency decreases. Why? Because it has a force of friction. The air is present. Air, when it is moving, air is resisting against this movement. It has a friction. Due to this friction energy, the movement, or you can say frequency of top, decreases with time. So there is a decrease in frequency of this. So when there is a decrease in frequency of this, so you get a very important aspect. It keep decreasing its frequency, and one time reaches when its frequency becomes very, very low. If you focus the last moments of top, let's say when you place this, it is clockwise rotating. Whenever its spin becomes zero, if it was rotating clockwise, in the end, it always rotates anti-clockwise. If you are rotating it anti-clockwise, when it stops its spin, it rotates clockwise. In the end, this is called precession. All right, this is called precession. In that case, when top is falling down, its axis changes. Axis of magnetic field change. When it's spinning, its axis is likewise. This is what I have presented. Look at this is the top. This is the top. So this is the movement. It is spinning, and just like this, it is spinning. So this is the direction of magnetic field. But when it process, when it change its frequency, so this one basically this axis is changed and it process. So when it is falling, so its processional orbit is this one. So it changes its axis and it is revolving around this. Then it rotates its axis. This is called processional orbit. So just those who doesn't are familiar with top, take a top from the market, spin it, and focus on its end. When it ends, if it is rotated, spinning clockwise, it ends with anti-clockwise movement. If it is spinning anti-clockwise, it ends with clockwise movement. Observe this in the top. Why? Because when this top is spinning, it is producing a magnetic field. But this magnetic field is less than the magnetic field of Earth. When its spinning is decreased, frequency decrease, spin decreases. When spin is decreasing, magnetic field is decreasing. Earth magnetic field is constant, which we call applied magnetic field. So what happens to that? In the end, its spin rotates. Because when its frequency becomes zero, it falls down. Once it falls down, its magnetic field becomes zero. So its frequency rotates from clockwise to anti-clockwise and anti-clockwise to clockwise. Observe this stop yourself. This is an experiment you can see. This small electron, proton, or neutron, they are also like a top. They are spinning. But when they are resonated, electromagnetic radiations are provided, so they spin inwards. This is called precessional energy. Before inversion of spin, they have a precessional orbit. This is something that I wanted to present. So in next lecture tomorrow, I shall focus on a very simple aspect that I have presented here. So I shall focus there, but this is a very basic principle which was interesting. Just you see yourself and study the magnetism. More you study magnetism in your physics books, definitely in second year books, you are having a magnetism and electricity chapter. Study that. What is the right thumb rule or right hand rule, right thumb rule. So study that as well. Similarly, what is precessional orbit, precessional energy, etc. Study magnetism yourself. Is prerequisite for this NMR.